Well, we can get started. See if people will come. Well, I guess we can first do a quick recap and then we will look into something we missed last week. On Monday, I bring my webcam today. So we can do some of the cool stuff. Yeah, and we will talk about the midterm assignment later. We should delay it, I guess, because it's next Wednesday. It feels too rush. Anyway, just a quick recap. What we were talking about Monday. We were talking about images. So displaying images is basically, just like treating them as rectangle. For most part. There's much more, but I mean, that's the most easy things. You load an image with this load image thing, and you have this P image, processing image. Basically, that's the image object. And once you load it, you can just treat them as like rectangle. So, image, that's the object that you have, where it should be, how big it should be. That's it. But more interestingly is that once you have these image, you can actually update the pixels. So you can do image.pixels. That would be the array of all the pixels. And again, it's 1D, which is very counterintuitive, but that's just how it works. So you can do low pixels so that it turn this image into this pixel array. And once you do something on the pixels, then you have to do update pixel back to the images. So these two things essentially are capturing the same thing, but they are not always synchronized. You have to explicitly do low pixels and update pixels. And unfortunately, on Monday, somehow this stopped working. But technically, you can do something like this. I'm still trying to figure out why. But somehow, I guess from processing 3 to 4, the update just break this. But technically, you can do something like this. You can, work with the pixels and, do all sort of, pixel level manipulation on the image, basically. So here, basically, you want to update the pixel. And the other example is this pointillism, where, essentially you read an image. And then for each pixel of the image, you try to draw it as a circle of, the color that's, semi-transparent, so that you together create this, oil painting-ish style. Cool. So, basically pick a random pixel and then you find the color of that pixel and then you draw the circle with some, alpha value of 100. So it's not, semi-transparent. And then you draw a circle. So last week we tried to do this webcam capture, but somehow we failed because our webcam is being used for Zoom. So let's see how we can do it today. So you can actually do webcam capture. Let me find the code. So this is the webcam. So now one will be on Zoom and the other, this webcam, will be used in this example. Okay, so this is the webcam capture. So you import the video library, and now you have this thing, capture video. That's basically the webcam thing. So basically what you would do is just to do new capture. This 640 480. This is the camera resolution for your webcam, and you just do start. And one of the thing of that is that you have to do this whenever you get the new webcam capture event. You want to read it into this object so that once you code this video, put it as an image, you will get that frame. Cool. Let's do it. So image video 00. Hopefully it works. Okay, cool. It's showing up here. So this is essentially this webcam image. I can show it real time. And if you want to mirror it, you can actually turn it the other way. Because you likely couldn't see why it's kind of awkward. So, but mostly, whenever you are working with webcam-based, games or, interface, if you want the user to look at the webcam output, then likely you want them to be mirrored. So you can turn it around. So you can flip it. So this will be the flip version. Then if I look at it, it will be more natural. So this is essentially how you do the flipping thing. Let me show how it works. Where is that mirroring thing? Somewhere. Somewhere here. Almost. Oh, yeah, here, that is. So basically you want to do the scale minus 1, 1. So what's going on? I think I have a figure for that. No. I think I have a figure for that. Let me find it. Okay, unfortunately it's gone. But anyway, let's dig into what's going on here. So that's essentially what's going on. So, you have an image video 0, 0. This will be the original thing. So in the next class, we will talk about this transformation, but you can sort of get a sense of what's going on. So scale minus 1, 1, that will basically turn this grid system. So this is our grid system, right? To the right, to the bottom. This is our grid system. And if you do scale minus 1, 1, basically this will be x-axis, y-axis. So now x-axis will be flipped. So now the x-axis will point this way. So if you do the same thing, image video 0, 0, it will draw this poo image to the left, and there's nothing show on the canvas. So technically, you have to do additional thing. You have to move this video to negative video that width so that you show it. So that's why you need to do this, scale minus 1, 1, and then image video, negative video width to 0, because you want to, move the thing to the correct place where your canvas is. And the scale is basically flipping that axis. Cool. So we can actually do a lot of more with the webcam. Cool. So this is the deep vision library we talked a little bit about. So you can actually install it on in processing. Let me find an example. Cool. So the first example would be, this is it. This is like a small, tiny object detection thing. So to install that deep vision thing, you would click that manage tools, and then you will be here. Click at the libraries, and then find this deep vision thing. And somehow there's a bug in processing 4. Whenever you install it, it will be gone. But it's actually installed. So you just find this and then click install. Then you can get it. So now it's already installed, even though it doesn't shows up. But anyway, this is what we can do. So this will be object detector, deep learning base. Let me see if I can move it here. So, you see me and there's the person thing happening. And if you grab some random object, I don't know, cell phone, what else? This pen. Hopefully you will catch it. Too hard. Anyway, maybe on my clothes better. Okay, it says it's a tie. But anyway, you can do all sort of things. Some of the thing that it might not remote. It says remote, no. Yeah, it says remote, so it's correctly things. But some of those things it likely doesn't know what those are. But anyway, you can actually do a lot of things in processing. This is showing just object detector that's deep learning based. So they will do all sort of stuff. It's a GitHub repository, but basically they will grab this YOLO network, which is a deep learning network, and it will run it on the fly for each single frame. So you can do all sort of things. I think you also recognize hands, I guess. But anyway, bags, whatever, water bottle, things like that. So these are some of the examples that's pretty cool, but there is also, object detection, object recognition, object segmentation, key point detection, depth estimation, style transfer, and super resolution. So I will basically just go through some of the examples to show you what those could be. Cool. So there's also like the one that I show object detection, but now this is like a hand detector, which could be very fun if you want to build an interactive game where it basically is the same YOLO network where it's just doing object detection, but now it's just being trained specifically to do hand detection. And it do much better on hand and it won't detect anything else. So cool. This is the hand detector. So you can imagine that, you can create a very fun game where you basically just, if you want to get the center of the hand, you can basically just grab that red rectangle and you get the middle point so that you can create like a game where you can use your hands to control, something. So this is like a hand detector, but somehow it keep recognizing my face as a hand, which is untrue. There's something else. Let me see what else we have. Facial landmark. This is also interesting, where it can, not only detect your face, but on the landmark. So it will have a markers on your face. So you can, you can determine the direction of your face and where the eyes are. So you can imagine like this is essentially what you're doing when you are doing zoom and then the cat face thing. So once you have the facial landmarks, then you can apply special effects on your face and it will track you. So during COVID era, there's a bunch of funny video where lawyer become a cat. That's likely something like this. So you can also do those in processing, just that you need to install those. There's a bunch more, but I guess the last one I want to show is this very cool neural style transfer. So we could go through a little bit. So YOLO is basically like the object detector. So essentially what it's going is that, look at the image and it tries to do all the bounding box, try to see whether there are some objects that's being done by deep learning. And basically the output will be something like this, where you have the dog and you want to know, you also want to do object detection at the same time. So you want to first identify whether there's an object and what that object is. So basically this is like determine whether there's an object, and this is to see whether there's a dog here, whether there's a bike here, and you combine these two information so that well, this bounding box, captured a dog, and this bounding box captured a bicycle. That's essentially what this YOLO object detector is working. There's a bunch more, but I guess the more interesting one is the neural style transfer thing. So think about what we want to do, it's like Mona Lisa, this is the content, and you want to turn it into some other style, say this Van Gogh Starry Night style, then you can do something like this. So basically you transfer the touch and, the color, kind of the use of color, more texture thing to the content that you have. So you can do all sort of like different style transfer based on the input image, the reference image that you have. So I can do a demo here. So this is the neural style transfer thing. It works. It would be slower than the other. So what you will see now is like left and right. So this is the input. That is the style transfer thing. So you can actually provide different image so that this model will use that image as a reference to the input. So now it's using the webcam and then directly transferring my image into another style. Question on this? Well, one thing said about deep learning is that, yeah, it's like a black box. It works, but it's like if you want to understand it, you have to do a lot of math and read the paper. But technically, these are some of the interesting things, cutting edge, um, cool stuff that you can do. Even within processing, you can still import these very powerful deep learning model to do also thing. And the hand thing, the hand detector, the facial landmark detection, those are very fun way to interact with webcam so that you can build some interactive installation of things like that. Cool. So mainly just showcasing how flexible it could be, and you can actually grab additional plugins so that processing can be more interactive using these webcam, computer vision, or deep learning models. Cool. On the midterm assignment, originally I planned to do it next Wednesday, but I feel like it's a bit too rushed. Is it? That's so after the fall break, we can actually do it on October 15th. So that would be after the fall break. Originally I was like, we shouldn't just keep this thing going on during the fall break. You should just have fun, or I don't know, do other midterm, but now it seems to rush. So how about let's just move the showcase to October 15th, and then maybe next Wednesday we will just start talking a little bit about Max. It's still mainly we won't get into details, so it's fine. Sounds good. Okay, awesome. And the final deal will be still on that day. So, after your showcase on this day, at that day, try to submit it. I guess that's the idea. Cool. So basically we will swap this. So we would do the showcase 2 weeks later. Hopefully more time to think about what you want to do. And there's some time for you. But it will be October 15th. Nice. Cool. Cool. Other than that, again, it's just building your own music visualizer. So by music visualizer, it will, either you can sing if you want to do live demo using microphone, or likely you will be grabbing some music audio files to do it. So it will be open-ended, whatever you like, use whatever you learn from the class and beyond. Definitely not enough from the class, likely. The rubrics, the only constraint is that you need to use two of the following concepts: loops and recursion, or recursion, I guess, data structures, classes, and objects. Yeah, so that will be 10 points. Clear documentation in your code. So the idea is that, someone else should be able to understand what your code is going on in a high level without talking to you. That's usually the purpose of documentation. And then live demo in class on October 15th. Questions on the midterm assignment? Cool. So feel free to explore whatever you like. We have so many examples in class, so feel free to use them. The only, just watch out for license, and, technically we are not releasing those, so feel free to use it. But you should do something on top of, just grabbing someone else GitHub and then just run it. You should do something more than that. That's the only requirement. But feel free to use whatever you found online or, in class. Cool. So not last week, on Monday, we showed some of the cool examples. I don't think I showed this. This is pretty cool. Even though it's likely too challenging, to actually do this. There's This is actually a particle system. It's very challenging. We don't even cover it in class. But this is also something you can do with processing. Pretty nice. So basically, this is like a particle system where you have so many dots and different lines, but it will follow the contour of your input images. And technically, it's not, music visualizer. It's like more like you've done this generative art and then you add music to it. But this sort of give you some inspiration of, these are some of the more, capable way of using processing. Cool. And this is another example.
Anyone who knows me knows I love Royal Kingdom.
This is so bad. This is another like very cool using processing. So just sort of like the pointless thing that we talk in class, but now exploring different way of drawing or reimagining the same image in a different shape. And, looking at this, likely not too challenging to imagine how you do it. It's basically, sort of like the whole lesson, but you play with the shapes and how blend colors. So this is actually Seoul Namsan Tower, which I didn't visit last week. Cool. And there's also one nice website that you can look into called Open Processing. So Open Processing is actually a huge community of creative coders, educators, and designers working on processing, and it's called Open Processing. So unlike OpenAI, I guess, it's truly open. So you can see all the examples, and you will have, the code that they run those. And you can go into this open processing gallery and you will see all sort of like different examples like this, cactus, generative art, generating art for mountains, city landscape, all sort of things. A lot of those are, dynamic. Some of them are, static, but you can see the code. So actually processing can be run on different platforms. So the thing we talk in class is the Java base one. So, this thing is the Java one. And if you click here, there's actually other modes. You can actually do p5.js, Python, R, blah, blah, blah. But this IDE is essentially for Java mostly. But the other big chunk of stuff is actually for PFJS. So this is actually running in JavaScript. Everything is web-based. You can actually also click this thing, create a sketch. Then you can run p5.js on the fly. So p5.js, because it's in JavaScript, so the syntax is a little bit different from Java, what we are writing in our standalone processing, but pretty much the concept is the same. But now you want to switch to JavaScript syntax, basically. There's also Python, processing.py, not well maintained, but still kind of maintained, and there's Android and Raspberry Pi, then it's even less maintained. But anyway, processing can be run on different platforms, processing for like a high level concepts of a language. It can be implemented in different case. So P5.js is likely the other thing you might care about. So, you know, on open processing and some of the other platform, sometimes there's even more resources on P5.js than the original processing in Java, because P5.js allow you to do web programming. So ideal for web programming, and it can be embedded on websites. So, you know, nowadays, a lot of things happen on website. So you can even, you know, imagine your personal website. At the background, there will be some pf.js enabled generative art. But I guess the core is that slightly different syntax, but the same design philosophy. You can also click on this to get the online editor, or, you know, on open processing, you also have those. So you can, oops, donation. So you can actually just run these online. So, you know, I will try here. I don't know if it works. Circle. Let's see. Oops, wrong button. Yeah, so you can pretty much do the same thing. So most of the thing is the same. You know, create canvas is different from, you know, size. So, you know, syntax wise, it will be JavaScript. But, you know, you can find equivalent mostly. And you can do also thing, and it will be real time showing here. So in some case, it's actually easier than, you know, processing. But processing allow you to do, you know, integrate with Java. So if you want to build a standalone application, then processing would be the way to go. But if you want to do web-based developing, then p5.js would be ideal. Cool. So that's pretty much it. I think we've covered everything in this slide deck. Somehow it's a huge slide deck. Yeah, one thing I didn't, yeah, you can actually do the same thing, create a sketch, then you will find something. I should show the open processing. Yeah. So this is the open processing thing. So yeah, this is a nice example. So whenever you click this or you do refresh, the background will be a generative art that's just showcasing how P5.js can work. So this is actually running on the fly on your browser, actually. Usually when I refresh, it will be another one. Somehow it doesn't like it, or every day it would change one. But anyway, if you click on discover, you will see a bunch of different things. Pretty cool. So some of them are static, some of them will be dynamic. I don't know, this look cool. Oh, that's so cool. Anyway, I don't know. And you can actually click this to see the code. So this is open processing, truly open. It has all the things. And so one thing you will notice about, you know, p5.js is that now you have like style.css, index.html. So it's actually writing JavaScript, and it's more, you know, web programming. Let's look at this Apple thing. Well, this is a static art. And there's all sort of different things. This is also cool. This is like a 3D case. You can imagine this could be, I don't know, like a CD turning. I don't know. Anyway, you can actually look at their code. You can also just change it. So it's sort of like GitHub. You can fork, and, you know, it will show up there. Lava flow. It's running. So, and there's also license. So be sure to check their license. And you can click this create sketch and run the same thing. So pretty much sort of similar to the p5.js, you know, sketch pad. You can run it and get whatever you like. You can also set it up so that it will be side by side rather than opening up a new place. Anyway, there's more to explore if you want to explore on that. Cool. Questions on assignments or oh, good. So today we will talk about transformations and 3D graphics. We won't get into details on 3D graphics. It's so complicated. So anyway, to give you the sense, what the transformations and 3D graphics world is like in processing. Cool. Let me grab the slides. Cool. So we talk a little bit about transformations, the way how we flip the webcam, but also at some point we were talking about the tree thing, the recursive tree thing. We also talk a little bit about transformation. So what is transformation? This is important for 3D graphics because everything in 3D will be only transformation based. So what's transformation? Basically, transformation is playing about the axis system rather than, moving object around. But now we just directly change the axis. So think about a case where we want to do a rotated square, then how would you do it? There's simply no easy way to do this, unless you do a, quad, 4 points, and then you do this. But it doesn't sound elegant, right? So the idea of transformation is to support all these, it's still a square, but it's like tilted, rotated. How can we do it without, too much weird syntax? So here, basically, what you want to do is to look at this. What you want to do is to think about how you play with this axis system so that you can draw that thing easily. So think about this is our original axis system where point to the right, point to the bottom, and the origin is over there. So the first thing here, what we want to do, this is a very simple thing. So you change rectangle mode to center, and you do translate, you do rotate, and then you just throw a square at 0, 0. So what happened here is that, you have the original axis. Now you do translate 100, 100. What it will happen is that this axis will move to the new point where you translate it for 100, 100. So now it will move to the right bottom part. And now you can do rotate pi/4. Then it will rotate for, 45 degree. So you turn this axis 45 degree away. And now you just draw the square at 0, 0, 100. So imagine this is your new axis. You draw something at 0, 0 because you have like rectangle mode in center, and then you draw 100. So you get the square there. So basically, this is essentially the idea where you are not, defining where essentially that thing is and like the rotation, but rather you just use a more elegant way where you just change the axis, turn the axis, rotate the axis, and then you draw something on top of that. So you can actually also do the same thing. You can keep moving. So once now your, axis is here. So at this point, once you translate and rotate, the axis will stay here, and then you can keep moving it. So now you translate 100, 100. You will actually move to this point. So now you are on the new axis. So when you do translate 100, 100, it will actually move to this point on the new axis, not the original axis. And then you keep rotating it. And then you can draw another square. So you can imagine like this create some flexibility, but also some chaos in that, your axis could be changing over time. So one thing you could do is that you can actually reverse that rotation, and then you move the translate thing. So there's a sort of thing you can do. So you can rotate back to revert the rotation, but more elegantly, what you can do is just to do this reset matrix. So whenever you do reset matrix, it will just turn the whatever axis you are at all the way back to the original matrix. So once you do reset matrix, now if you want to draw something here, then you just return to the original matrix and you do the new translate and rotate thing. So that's the whole idea of transformation matrix. There's also the thing you can do. This is the original square. So imagine you are drawing square 100, 100, 100. So starting at 100, you draw a 100, size square. You can do scale too. So what happens, when we talk about the mirroring thing, we are talking about -1, so you flip it. But if you don't do minus thing, you just do 2, then it will basically be scale 2, 2. So basically x-axis will be double, y-axis will be double. So now this grid system will become something like this. So now if you draw the same square, it will be much larger. So you can also play with this scaling thing on the transformation matrix. And you can even do, half size. So you can do scale to 1. So the x-axis will be double, but y-axis will be the same. So now the square becomes a rectangle. And that's essentially what we were talking about when we were talking about, mirroring an image. So we basically do scale, but we don't change the size. We basically just flip it. So scale -1, 1, it will turn this axis, flip it on the x-axis, but you didn't change the size of that. And now, unfortunately, our canvas will be here. It's still at the original position. So you have to move the image back. So now you essentially want to do image video minus video with 0. So that's some of the, details, nuance on doing these. But technically, you can do a lot of things by using these matrix transformation. And as I said, there's, reset matrix to reset to the identity matrix. So identity matrix is the original, the one that you are familiar with. So you can do all whatever stuff, but at the end, you can reset it to the original one. But more interesting, there's also this push matrix and pop matrix that can temporarily store what you have so that you can come back later. So the push matrix thing is sort of like, think about there's like a recycle bin, not recycle bin, like a storage, like a drawer, I guess. So this is thing called matrix stack, but think about it like a drawer. So you have, you started with like identity matrix and you change to some shape. Like, you play with your transformation matrix and imagine that now this is the transformation matrix that you have. Then you can do one thing is about, push matrix. So now you can temporarily store this matrix into this matrix stack. And then you can say, reset matrix and then work on whatever stuff. And this thing will temporarily be stored in your drawer. And then once you do pop matrix, then you can retrieve that, storage things back. And these have the behavior of first in, last out. It's a little bit tricky. But anyway, the idea, here are some slides I grabbed somewhere else. But basically, stack is, first in, last out, meaning that, you put stuff one at a time into it. And then when you grab it, you will take the last one that you put in. But that's different from the queue where you put everything in, but you grab stuff from the bottom. So everything will be in the same order. So that's the difference between the stack and queue. So what we are seeing here, this thing is a metric stack. So, first in, last out. That's the most important thing that we should know about. First in, last out, and for the queue is first in, first out. So the easiest way is to look at this. So this is basically like a stack. So, you put something on top of it, and the first thing you grab is the last one you put. For first in, first out, it would be more like a, cup dispenser where, you put everything in, but you grab stuff at the bottom. Anyway, what can we do with all these things? So one thing, for a 3D, we will see later, everything is about matrix transformation. But for now, think about what's going on with all these 2D things. You can actually do the spinning object thing. So this is like an object called rotator. So you declare an array of rotator objects. What you can do is to initialize each rotator with a random position, size, and rotation speed. And so the idea is that each piece square will rotate on their own. So this is very tricky, right? Because if you think about how you want to write it, it will be rotator.spin, rotator.display. But, how do you enable that? So what we would do is, again, theta plus equals speed. That's how you spin the rotator, right? But how essentially you do this is through, look at the display function. So whenever you want to start with this, you will say, whatever matrix you have, you put the matrix, current matrix, to the matrix stack to temporarily store that. And then now you work with this spinning object. So now you have translate and rotate. So now you go back to this object and then you turn it. And then you pop matrix to get the original matrix back to it. So this is sort of the way that you can work with these different matrix system. That's why we want this push and pop thing. So that you can temporarily store a matrix without ruining everything. Because, for these objects, each single object, they are manipulating the axis themselves. So you don't want to, at the end, you end up with a weird, metric system. This could also be done with reset metrics, but the idea is the same. Question on this? I guess the idea is that there's just no single easy way that you can spin a square or a random shape. So the only way you can do it is by working with the axis. So you turn the axis rather than the object itself. And we also talk about this recursive tree at some point. Basically, you would just, when we talk about recursion. So the idea is that you have something like h, the height, and then you will grow it with some fixed theta, but it will be shorter, like say 2/3 the original, length. And then at this point, you will do the same thing, two branch, slightly different angle, again, 2/3 this size, and then you go through each of these and then do this, symmetric branches. And then you keep doing it so that you get that thing at the right. And so this is just a, it's just a animation to show when you change the angle. Cool. Yeah, I won't grab it. But anyway, that's the idea. So if you look at the code, you will see a bunch of that push metrics and pop metric thing. So the idea is that, when you are working at different places, each single place, you want to do this transformation. You want to slightly tilt it rather than, computing, you can imagine like you can use like, I don't know, sine, cosine to compute where exactly you are at each point, but it seems crazy. So the easiest way is that you just tilt the axis and then you move up, tilt the axis, and then you move up. So that's essentially what's going on. So, in each branch, you will have this stop condition, of course, and you will have like these two branch thing to do the recursive thing. But more importantly, how these push metrics work. So when you work on the right branch, you will store the original metrics first into the metric stack. And now you do all the things that you like. Rotate theta. So, at some point, imagine that you are at this branch. So this would be your current axis, something like this. So now you store this matrix to the matrix stack, this green thing. And then now you start working with this thing. You want to rotate theta because you want to grow the other. So you rotate this thing. And now you do this branch edge scale. If you do this line thing, so you actually grow like a branch here. And then you would do pop metrics. So you now grab this back. So you remove the new, temporarily, axis. And then you turn to the other way. To draw the other branch. So this way you can get the two branches by just working with the metric system. So this like push and pop is important because that allows you to, temporarily store this metric and then do all the stuff that you rotate and do all the things and then, do all the things you like. That will be a new matrix, but now you pop matrix to get the original matrix back here. And then you start working with the left branch. Now, when you work with the left branch, you still don't want to forget about where you are. So you push again to put it into the matrix thing. And then you start working with all the new, things to the left. And then once you are done, then you pop the original matrix back. So this is essentially how you enable this recursive tree. And that's all about playing with this metric system because it's much easier. And so one thing you might wonder is that why shouldn't we just reset metrics to the original metrics? So technically it doesn't work because especially for this recursive case. So for this simple case, you can actually just reset metrics so that, revert it back and then you turn to that specific position. But in this recursive tree case, it's much harder to do reset reset metrics because technically the idea of, the recursive tree is that, you start with this point and you grow this branch and you start at this point and then you want to grow this branch. And then at this point, you want to grow the other two branch. So each time you don't want to reset to the original matrix. So think about when you are at this point, you want to jump to this point and then you want to turn the matrix. But once you are done, you actually want to come back to the previous matrix rather than the original matrix. So if you do reset matrix, you will go all the way back to the original one. But that's not what you want. You want to go to the right branch, turn back to the previous branch, and then you go to the left branch, and then go back to the original branch. So that's why you want to use push and pop so that you go to the immediately previous one rather than the original one. So there's some tiny nuance where reset max just doesn't work. Cool. I guess we are too deep into metric transformation. Likely, hopefully, you won't get into this thing. But if you want to enable some of these cool, recursion thing and some of these rotation of objects, then transformation is the way to go. It could get real tricky, but still more elegant than if you just want to do all the sine cosine stuff. Cool. For the rest, we will talk about 3D. 3D is very tricky in processing, but I guess 3D is tricky in any sense because, laptop is 2D and everything in 3D is very tricky to define. But anyway, you can actually do 3D graphics in processing. We will go into, super deep into this, but to just scratch the surface about you can do 3D graphics and how they kind of look like in processing. So how can you do that? So when you initialize the canvas, canvas originally usually is like 2D. So if you want to do 3D, it will be size the same, but now you do this P3D thing. So P3D again, everything started with P is like a processing object. So this is like P3D object. But basically it will tell the whole processing to enable this 3D mode. And there's only 3 primitive shape that you can do: box, actually 2: box size, or box width, height, depth, and then sphere radius. That's the only 2 shape that you can do in 3D. So unlike in 2D case, you have rectangle, you have claw, you have circle, you have ellipse, well, pretty much still box and sphere-like. But in 3D is much trickier. So everything else you have to rely on transformation. So imagine if you want like I don't know, something else, then you should just work with sphere and box to turn it into something else. So this is like the first example: size 400, P3D. And you translate as somewhere else, and you can rotate and you can fill so that you show that. I think I have some example. Let me see if I can find it. Cool. It's not what I'm looking for. Box. But this is it. Box. So it will look like something like this. Oops. Let me do it again. Yeah. So you can do a 3D box. You can, rotate it more, 0.6. Let's just do mouse Y divided by 400. Okay, so this will be 0. Oh, that will be mouse Y. Let's do mouse X. So mouse X divided by 400 will be, this will be 0. It's not working. Did I mess it up? Anyway, let's just reset it. Rotate Y 0 would be, is this showing? Oh yeah, showing up. So this would be the original upright view of it. So that would be the way you look at it. So XYZ would be, so X, Y, very hard to draw it. But anyway, rotate Y would be how you rotate against the Y axis. So you can do 0.1 to see how it gradually move. We can actually just write it into a better case. Void. Let's just do a slow animation, frame rate 1, so that it will be 1 FPS. So for every second, we would just increase the angle for 0.1. Theta equal to 0 at the beginning. And we will rotate Y for theta. And, at the end, we will have theta plus equal 0.1. So let's see how it goes. Cool. So you will gradually move over We have to set the background, otherwise it will just keep showing that. So background 50. So well, kind of cool. You see that it just turn into a like a cool cylinder. Background. Okay. So you can see that basically is turning too dark. Yeah. So now you can see that it's basically turning around the y-axis, and you can also do rotate x. Kind of slow. Rotate x. So now the x-axis. So this x-axis, y-axis. So now it will turn along the x-axis, and then you can also turn along the z-axis. So the z-axis will be the one point to you. So the axis. So there's basically, you know, three axes. It's a little bit tricky. So xy will be the original one, xy, but z will be the one that point to you. That's why you see this thing is like rotated this way. Anyway, that's 3D. So you have x, y, z in a different angle. So basically that's it. Let's just don't close it. Cool. So that's box. We could also have sphere. So sphere is a little bit more tricky because you have to do this lights thing. Otherwise, it will look like this. So if you draw a sphere and you don't provide light in 3D, it will just be flat and you won't see the texture of it. So this is basically the lights thing. So in 3D, you also have to need to worry about, you know, you are drawing something in the 3D space. Where are you looking at that 3D thing, and where are the lights? So that's all the details about, you know, 3D. So it's much trickier. So if you look at the sphere, now we do no stroke and we do light. So that's look like that. If you remove this light thing, it will be flat because there's no reflection. You don't see the texture of it. If you get rid of the stroke, you sort of now get rid of the no stroke. So now you have the stroke. So now you see the details of a sphere. Actually, a sphere is not a sphere in processing. It's basically a mesh of triangularized mesh of circle. So it's actually a bunch of triangle together form that shape. And if you even do no fill, you can see the other side of that. So if you have fill, you only see the forward side. Now, if you do no fill, you also see the opposite side. So it's actually technically a bunch of triangles to form a circle, because that's essentially how you do it. And you can also do this very cool animation where you just do sphere details. So sphere details will determine how many triangles you are doing. So in this animation, basically, I was just trying to, you know, increase resolution plus equal 1. So, you know, the resolution become larger and larger. So initially you will see that it doesn't look like a sphere because too few triangle, but over time it becomes more like a sphere. But, you know, the computation cost will be higher. Your laptop will lag. Anyway, I guess that's pretty much it about 3D. There's additional tricks. So one thing about perspective and orthographic projections. So usually we are looking at this perspective. This is the default way. So perspective meaning that, you know, the closer an object, distance matters basically. So, you know, the closer the object is, the bigger it is. You know, this will be smaller. But if you are using this mode, ortho mode, which is not default, this is the default way. If you're using this, then everything will be flattened. So everything will look the same. So you are sort of like the God view point of view, or, you know, you are so far away, everything look flat. But perspective is usually the case, and that's actually create a 3D immersive perspective. So this is usually the way how we do it. So distance matters. In that case, distance doesn't matter. And usually we are in the perspective mode, unless you want to do some artistic design in ortho mode. Anyway, there's also light. Light is very tricky in processing again. There's all sort of light. So when you enable that, sphere here, when you call this light, by default, you will create a set of lights. You can Google and see what those default lights will be. But you can also set all the lights. So there will be ambient lights. It will be, sort of like in this space, everything is diffused. So you will get light from everywhere. And there will be also direction lights. This will be sunlight light. So, sunlight will be parallel lights coming in one direction. You can also set up a point light where there's like just one point light. So something, I don't know, more like this light bulb or, the projector where it will just, point light everywhere. Anyways, so projector is actually more like spotlight, not point light. So spotlight will be, you have to define a point source and you will just create that cone that will, do the light. So you can do all sort of lights. It become very tricky especially when you want to do all sort of thing. But you can actually do this creepy eyes into 3D mode just using the lights. So the idea is that now you have the spotlight idea, or even just using the direction light is much easier. So you can use direction light at different direction. So now your mouse X and mouse Y will just control where the direction of the lights coming in. Then you can turn this creepy eye into 3D, which is pretty interesting. And if you look at the code, it's not that tricky actually. So basically what you want to see is where the direction will be. So direction X would be something depends on mouse X minus width divided by 2 divided by width divided by 2.0. So basically you want to see where the X direction is, where the Y direction is, and you want to set up a direction light from that your mouse X, mouse Y, all the way to this two sphere. Basically, that's the idea. So now, if your mouse here, then there will be a light coming from your mouse, and that's a direction, no light. Cool. You can also set up the material. Now, 3D, everything just get more complex. You can also set up the material. So, this sphere, you can set up how reflective it is on different light source. So ambient would be, like how reflective it is. Emissive, it's like, does it actually show some color? Like emitting source. And shyness, specular. So you can set a sort of like texture and, how it play with lights in 3D. Anyway, we won't get into details. I think 3D is very tricky. You can actually look at like open processing. There's a bunch of examples, but things could be real tricky in 3D because, as these few slides could give you the sense, first, you only have box and sphere basically. And then everything else, you have to do transformation. You have to move these things, you have to do rotate, you have to do translate. There's no way you can just easily place something in the 3D space. You have to rely on transformation mostly. And at the same time, there's also the slide thing you have to take care about, even though default one could be good enough. But sometimes you want to, play with the lights. And there's also this perspective thing, and there's also the camera thing. At some point, if you're doing the 3D, playing with 3D and processing, you can place some object in the field. So instead of rotating that object, you can also rotate how you view the thing. So there's so many dynamic components. So, rather than moving this object around and staying at the same place, you can also change the camera view. So that are, also that's also possible in processing. And all about the lights and material. Cool. So just quickly recap what we talk about for transformation and 3D. So 3D depends a lot on transformation, but transformation alone, even in 2D, you can do all sort of things, especially when you want to rotate something. It's very tricky. So basically what you can do is to change the axis rather than actually working with that object directly. So you want to, translate meaning you just move that axis and then you can rotate this axis so that now, you want to draw a square here. Now the square will be, rotated and, basically just being drawn on the new axis that you just defined. And that will allow you to do mirroring. And we talk about this matrix transforms, especially when you're doing recursive thing or, object-wise transformation. Then this push and pop matrix could be useful, or even just using the reset matrix would be useful. But basically you can push stuff to the matrix stack and then pop matrix stack. First in, last out. And stack versus queue is that stack will be first in, last out, queue will be first in, first out. So sometimes you will hear one to another space. That's a technical term in programming language where stack and queue is like two different data structure. Sometimes it's a bit confusing. But I guess if you have this image in your mind, then you will be fine. Cool. And we talk about in 3D, basically we only have box and sphere. Everything else you need to do translate, rotate, or the transformation to get those. And we also talk about, we have lights, which is very tricky. And perspective, we didn't go into it, but there's this camera thing that's very tricky because technically you are setting up a scene and then you are using the camera is where you're looking at it. So now there are so many moving variables. You can turn these, objects around, or you can move the camera. They could have different behavior depending on the light. So there are so many, factors going on in 3D. You have the scene, you have the lights, you have the camera. So moving each of these factors create a different things to think about shooting a movie, I guess. Cool. Yeah, but I guess the cool thing about it is that you can still do creepy eyes in 3D just by doing that direction light, which is pretty cool. Cool. I guess that's it for today. So again, we are moving our midterm showcase to October 15th. Cool. Next week, we will look at this. Hopefully, it's pretty cool. Motion and physics. So, just dive deeper into, we can actually create. So what's the difference between this and the bouncing balls is that now they collide. So there's some way you can handle collision in processing and create all sort of cool stuff and physics about, gravity. You can do force, dragging force, things like that. Cool. Do we have any assignment due? Oh yeah, next Monday we will have homework for due. That's the spectrum visualizer thing. Anyway, you should work on that first, and then for midterm assignment, think how you extend beyond that. We talk about the sound library. There's like beat detection, pitch detection, amplitude detection, FFT that we explore in homework 4. We talk about all the different things, image, videos, division stuff. So combine all those to think about what you want to do on midterm assignment. Cool. See you next Monday.